understand dynamic addressing for IPv6, let's first take a look at DHCP for IPv4. PC1 and PC2 have both received their IPv4 addressing information from a DHCP server. Most of this information, including the subnet mask, default gateway address, and DNS server address, is not unique and is the same information sent to all clients. This information is considered stateless. This means that a DHCP server is not maintaining state or keeping a record of who receives this information. However, the IPv4 addresses for each device are assigned from a pool, with each device getting a unique IPv4 address. This information is considered stateful. The DHCP server is maintaining state. It is keeping a record of which device receives which IPv4 address. In the case of DHCP for IPv4, the server keeps track of which device received which address based on the client's Ethernet MAC address. Notice that although each IPv4 address is unique, the network portion of the addresses are the same. It is only the host portion that makes each address unique. Dynamic addressing with IPv6 uses an ICMPv6 router advertisement message, which informs the clients how to dynamically obtain their IPv6 addressing information. An IPv6 router sends out router advertisement messages periodically. Cisco routers send them every 200 seconds. An RA message may also be sent anytime the router receives a router solicitation message from a device. Let's take a look at the RA message. A router advertisement message is sent to the all IPv6 devices multicast address FF02:1. The source IPv6 address of the RA message is the link local address of the router, in this case FE80:1. The RA message includes the network prefix and prefix length. This is the same network prefix as the router's global unicast address on this interface, a DNS server address, and one or more of the following configuration flags enabled. Both PC1 and PC2 have received the RA message. The network prefix and prefix length indicate their network address. The source IPv6 address gives the devices their default gateway address. The address of one or more DNS servers is typically included in the RA message. And in this example, the RA message only has the A flag enabled. This means that our devices will use SLAAC, stateless address auto configuration, for their IPv6 global unicast addresses. PC1 uses the network prefix information from the RA message and randomly creates its own interface ID, the host portion of the address. The interface ID is indicated in red. PC2 does the same. Notice that all the address information obtained by PC1 and PC2 is stateless. There is no server keeping track of which device has received which address. In this case, it means that a stateful DHCP server is not required.